third grade teachers. Today, we are going to take a look at Unit 1, Building a Strong Foundation. The purpose of this video is to provide an overview of the standards, intended pacing, and sample instructional strategies. In Chapter 1, we are going to review the AKS and the Indicators of Achievement, or the IOAs, for Unit 1. The AKS is the overarching knowledge and skills that students are expected to master. The IOAs are the learning objectives that allow students to demonstrate mastery of the AKS. The AKS and IOAs may not be taught in their entirety the first time they appear on the instructional calendar. Some AKS and IOAs will appear multiple times throughout the year. In Chapter 2 of the video, we will look to see how the AKS and IOAs in this unit are paced in detail. Welcome to 3rd grade Unit 1, Building a Strong Foundation. This unit has 3 AKS. On these slides, you will see the AKS and the IOAs, which will be taught in Unit 1. Just a reminder, at the end of each AKS and IOA, in parentheses, you will see that we have the state coding. That way, in case you are looking up resources on the Georgia DOE website, you are able to find resources to support that IOA and that AKS. Unit 1, Building a Foundation, continues the place value work that was mastered or completed in 2nd grade with numbers within 1,000. You've probably noticed that this AKS says that we will be working with numbers within 10,000. However, in this unit, we will only focus on numbers within 1,000. This is one of those AKS and IOAs that will repeat in a later unit. In AKS 1, IOA 1A, and IOA 1B, students will read and write multi-digit numbers, as well as compose or combine, and decompose or break apart numbers in various ways. We will use base 10 numerals, expanded form, base 10 language, and explore numbers being represented in multiple ways. Students will also use place value reasoning to compare numbers up to 1,000. We will develop place value understanding up to 10,000 later in Unit 4. AKS 2 and IOAs 2A and 2C require students to work to build fluency with addition and subtraction within 1,000. This AKS and IOAs continue the work with addition and subtraction within 1,000 that was taught in 2nd grade. IOA 2A involves students solving problems to add and subtract using part-whole thinking. They will continue working with all problem types, which include start unknown, change unknown, and result unknown. Students will continue to use a variety of strategies focusing on place value. This is another IOA that will be revisited in later units. Let's look at IOA 2C. This IOA is specific to Gwinnett, and because of this, you will not find a state coding in parentheses at the end of the IOA. However, you will find some resources for bar graphs embedded within some of the Georgia DOE state resources. With bar graphs, this is the first time that students are learning to read the information in the bar graph, where the scales are greater than 1. Finally, AKS 5 and IOA 5A are ones that will continue to appear in multiple units because they are not taught in isolation. IOA 5A is embedded within IOA 2C with the focus on bar graphs. Chapter 2, Unit Pacing. Our pacing guide is closely aligned with the state pacing. With the first year of new standards, we want to ensure we are following the expectations from the state of Georgia. The pacing guide is an example intended to model how instruction of the AKS and IOAs in each unit may be facilitated. but teachers should design pacing to be responsive to the learning needs of their students. Let's take a look at the Elementary Communication Center, or ECOM, to see where we can access our pacing guide for Unit 1. Here we are on the 3rd grade unit page for Unit 1. Let's scroll down to find the button for the pacing guide. Now let's look at the pacing guide to see how the AKS and IOAs have been paced out over the course of Unit 1. In this portion of the pacing guide, we see the name of the unit, the big ideas for the unit, and the suggested pacing. Unit 1 will focus on numerical reasoning, patterning and algebraic reasoning, and measurement and data reasoning. The suggested pacing for this unit is 3.5 weeks. In the next box, you will see the first AKS and IOA that will appear in the unit. Unit 1 will begin with AKS 1, IOA 1A, and 1B. This unit has been divided into 2 parts, a focus on place value and then a focus on adding and subtracting within 1,000. Remember, Unit 1 focuses only on whole numbers up to 1,000 as a foundation of the work and future units in 3rd grade. As we take a look at the pacing guide, you will see that the left-hand column will list the progression through concrete, representational, and abstract strategies. The bullets also indicate the learning objective for the day, as well as the suggested manipulatives. The right-hand column of the pacing guide shows the instructional resources that align to the intended learning objectives for each day of instruction. Some days you will see instructional resources linked for the numeracy components of a traditional teacher-led lesson. Other days, you may notice a task-based lesson, which will be your full numeracy block that day. You will also see resources from the Georgia DOE website, along with lessons from Georgia Reveal, our newly adopted resource. As you can see, as you begin to look at the beginning of Unit 1, with IOAs 1A and 1B, we suggest about 3 instructional days. These IOAs will be revisited in a later unit as we move to work with numbers up to 10,000. Now let's take a look at the second part of the unit. After this introduction with place value, we will move into AKS 2 and IOAs 2A and 2C, adding and subtracting within 1,000. This is the primary focus of Unit 1. You will also see that we will have a few days of instruction for bar graphs at the end of the unit. Remember, the left-hand column will guide your instruction with regards to learning targets, problem types, and the learning progression for these IOAs. We will begin this part of Unit 1 with addition strategies with 2 3-digit numbers without regrouping, using base 10 blocks, as we transition to representational strategies, all while using those expanded form equations. Specific problem types have been listed in the left-hand column, and the sample lesson plans on each day show you an example of how that problem type can be modeled for students. As students begin regrouping with addition, you will notice that we follow the same instructional learning progression, where we go back to concrete and modeling using those base 10 blocks. Again, we will continue to use that expanded form equation. In this abstract day, you will see that the partial sum strategy is introduced. Here, we included specific resources from Georgia Reveal as a suggested resource to support this instruction. Then, we move on to subtracting within 1,000, following the same progression as addition. we will begin subtracting two 3-digit numbers without regrouping, using base 10 blocks while including that expanded form equation. Also note that it's important to go ahead and start including a letter or symbol to represent the unknown quantity. This variable is an important piece that you'll see within lesson plans. Next, we will subtract with regrouping, moving towards more abstract strategies before ending the unit with a few days of bar graphs. It is important to note that students are not expected to master every addition and subtraction strategy taught. The goal is for students to use the strategy that is most effective and efficient for them. Chapter 3, Instructional Strategies. This portion of the video will highlight specific instructional strategies that will be utilized in this unit. Please refer to the Analyzing the Standards, or ATS, for guidance on additional instructional strategies for each IOA. Hello, third grade teachers. Let's take a look at this problem for AKS 1, IOA 1A. Tess represented this number using base 10 blocks. What is the value of the model she created? So our job is to take a look at this representation of base 10 blocks and try to decide what is the value of this model. Now, teachers, I'm also going to go through different ways to represent this number so you can explore this and make your own anchor chart with your students in your classroom. So first of all, let's take a look. And I know that these are my hundreds, my tens, and my ones. Students did learn this place value in 2nd grade. So I can use each of the base 10 blocks to help me figure out the value of each number. Okay, so I can clearly see the value of each place of each different digit in my number now that I have it broken down by place value. So if I start here, I see that I have 5 flats. And if I have 5 flats, that means that my hundreds has a value of 500. Okay. If I have 2 rods, that means that has a value of 20, because each rod is worth 10. And then finally, when I count, I will see that I have 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 9 units, or 9 ones. So one way to represent this number is representing it in expanded form. Okay, I can write the value of each digit. I can say, because I have 5 flats, that value is 500. I have 2 tens, or 20. And I have 9 ones. This is the expanded form of my number. Okay, so with this expanded form of my number, I can put it all together to find the total value of this number, because that is what the question is asking me to do. What is the value of the model she created? If I put each of these values together, okay, because this is my expanded form, if I push them all together, then that number is written in what we call base 10 numerals, or standard form, and that is 529. So we call this standard form. Another name to use for the way this number is written is base 10 numerals. Students may see either thing to represent just writing the number using the digits. So I can read this number as 529. Now remember, when I read a 3-digit number, I do not want to use the word and. Now, another way that I may represent this number is using what is called base 10 language. And with my base 10 language, I am just going to write the digit and the place that that digit is in. Now, it is very helpful to think about how I've written this number in expanded form. So if I have a 5 in my hundreds place, that digit is worth 5 hundredths. So I'm going to write out 5 hundredths. Okay. Next, I would write out the value of the digit in the tens place. And in this case, the digit is a 2. And I have 2 tens. Now, this is another example. You do not want to write the word and right here. I'm just going to separate with commas for right now. And I have a 9 in my ones place. So I have 9 ones. So base 10 language says that this number written this way is 5 hundredths, 2 tens, 9 ones. Okay, now these are all different ways that a student might see this number represented or a number represented. This is also different ways that a student might be asked to read or write a multi-digit number. Remember, we are only working with numbers within 1,000 for Unit 1. Now, one final way, teachers, that I want to show you is a different way to write this very same number using base 10 language. Okay, one way to think about this is looking at the number that I have. What is a different way that I can represent the exact same number? Because I might be asked to represent this number in a variety of ways. So one other way that I could represent this same number is if instead of saying that I have 5 hundredths, what if I only said I had 4 hundredths? Blue is the color. 4 hundredths. Okay, if I say that I only have 4 hundredths, I know I still have this 100 left, but remember, friends, this 100 is worth 10 tens. So if I have these 10 tens and these 2 tens, that means I have a total of 12 tens. And then also 9 ones. Okay, so I could keep going. For example, if I wanted to do 3 hundredths, then I would have 22 tens and 9 ones. Okay, I could also do the same thing where I keep my hundreds. Okay, oh, I keep my hundreds, but I only have 1 10. And then I'm going to take those 10 and I'm going to place them in the ones place, and I have 19 ones. All of those different base 10 languages mean the same thing. They represent the same number. So again, this is helping to reinforce that place value understanding for our students to help them to be able to understand how to read and write multi-digit numbers. Hey there, third grade teachers. Let's take a look at this problem for AKS 2, IOA 2A. This is an addition problem. We are going to be looking at some strategies that we can use to support our students when adding whole numbers within 1,000. It's important to remember that we model for students how to analyze a problem or a situation in order to make a decision for which operation we should use. Let's take a look at this one together. Sarah's Girl Scout troop sold 252 boxes of cookies in January and 164 boxes of cookies in February. How many boxes have they sold in January and February? So let's take a look. What is happening in our problem? Well, we know this problem is about how many cookie boxes have been sold. So I know that there have been 252 boxes sold in January, and then I know that there are 164 boxes sold in February. My question is asking me, how many boxes did they sell in January and February. So I want to know the amount sold in both months. So I'm going to use a part-whole diagram to help me organize my thinking. This will also help me to determine which strategy should I use in order to solve. So to draw my part-whole diagram, I'm going to draw a box, and I'm going to go ahead and divide it into pieces. So really, this is another way of looking at a bar diagram. So this top piece is equal to this top piece, or this bottom piece, okay? So if I take that top piece and divide it into two parts, I know that I had 252 boxes that were sold in January. And then we know we have 164 boxes that were sold in February. Okay. So those are the two parts that I know. But what I don't know is how many boxes they sold in January and February. So I'm going to use a variable for this problem, because a variable is used to represent an unknown quantity. And I don't know how many boxes that they sold in January and February. So this is going to be total for January and February. Okay. So that is my unknown. Sometimes you might also put a question mark there, but using a variable is a great way to help students be introduced to that unknown quantity. Variables are just letters that we use to represent. You might have seen it as an open square or a circle or a triangle before. So this year we are introducing that variable. So it's great to incorporate that as much as possible. So as I'm looking at this part-whole diagram, I see that these two parts I know, and I don't know this total piece. Well, I know if I added these two parts together, it would equal this part, because remember, this top piece is equal to this bottom piece. So I can write an addition equation. 252 plus 164 equals how many cookies sold in January and February. Okay. And remember, I could also put my C right here. I'm leaving it blank right now because that's where I'm going to put my answer. So you know what? Let's write the equation one more time for good measure underneath my part-whole thinking, and I'm going to write C for the unknown. So C is my unknown quantity, which is how many cookies were sold in January and February. Okay, I have my equation. So figuring out which operation to use and writing an equation is a great way to start off my problem. Now that I know that I'm going to be solving an addition strategy, then I can use what I know about addition. So to solve this, we can use base 10 blocks. Now, it is important to also note that using that concrete manipulative is always a great way to start out this unit. It's also a great way to support students in small groups for students who really need that hands-on approach to this understanding. In third grade, we will be working towards solving addition and subtraction up to 10,000. So it's really our goal to help support students and thinking more abstractly and moving towards that expanded form equation. So we're going to always pair our base 10 blocks, whether it's the actual blocks or a drawing, with the expanded form. And we're going to see what that looks like today. So let's take a look at a representation using base 10 blocks. Okay, when I look at the two numbers that I'm adding, I notice that they're both 3-digit numbers. They have digits in the hundreds, the tens, and the ones place. So I'm going to go ahead and label my place value chart with my hundreds, my tens, and my ones. Now I'm going to draw each add-in in my place value chart using base 10 blocks, and I'm going to write out what that expanded form is to help me add. So let's first look at 252. I like to use two different colors when I introduce this, just a visual way to help students see the different add-ins that you are adding. So let's represent 252. Now, remember, we've learned how to represent numbers in the first part of our unit. So that's where it's really important to apply that knowledge here. So I see I have a 2 in the hundreds place. So that means I have 2 hundreds. represents, or which looks like this. And then I have 5 tens. 1, 2, 3, 4, 5. There's these boxes. And then I have 2 ones. 1, 2. So, I forgot to write in my tens. Let's double check. 10, 20, 30, 40, 50. That makes sense because there's a 5 in the tens place. And then 2. So there's my first add-in, 252. Now let's take a look at our next add-in, 164. Okay, so I know there's a 1 in the hundreds place. There are 6 tens. 1, 2, 3, 4, 5, 6. And there are 4 ones. 1, 2, 3, 4. Okay, now let's make sure we've written out that expanded form equation for that number, 164. So remember, I have 100, 60, plus 4. Now I am adding these two values together. So there's my expanded form equation. So again, I'm going to pair these two pieces. So let's start in that ones place. I have 2 ones plus 4 ones. If I count all the ones in my ones place, 2 plus 4 is equal to 6. Okay, so there I've added my ones. Now let's go ahead and let's add together my tens. So if I'm unable to add 50 plus 60, I can always come over to this place value chart and I can count my tens in order to help me add them all together. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110. So my tens place in my place value chart, that tens column has 110. That's my value. Okay, I have 11 tens in the tens place. So a couple different ways that I can represent this. It is perfectly okay if students count 10, 20, 30, 40 and on, and I have 110. That's always okay to do. If you wanted to go ahead and group 10 tens to make a 100, that is okay too. Okay, lots of different ways to go ahead and group 10 tens to make 100, or you can represent as a number larger than 100 right here. That's okay. I'll show you what we can do with that in a moment. All right, and then finally, I'm going to add my hundreds, 100, 200, 300. Now, typically with our expanded form equations, I can just look at my numbers and know that's my hundreds, that's my tens, that's my ones. But here, I have more than 100 in that place value. So remember over here, these 10 tens is equal to another 100. So what I can do here is I can rewrite this as 300 plus 100 plus 10 plus 6, because this piece right here, that 100 plus 10 is that 100 and that 10. And then I have 400 plus 10 plus 6 for a total of 416. So my answer written in standard form or base 10 numerals is 416. There were 416 cookies sold in January and February. So that is a way to use your base 10 blocks along with your expanded form equations. Now, again, it's totally okay right here. Instead of writing 110, if you went ahead and wrote the 100 and the 10, as long as you showed that you grouped your 10 tens as your 100, perfectly okay. Now let's take a look at one more strategy that can help support us here with addition, and that is using partial sums. Okay. So with partial sums, I'm going to go ahead and write my problem again. But this time, I'm going to stack those numbers and line them up based on place value. Okay? Move this up a little bit so you can see better. There we go. So now, I'm still going to start adding in the ones, then the tens, and then the hundreds. And I'm going to show out to the side those partial sums that I'm adding each time. So at first, I'm adding just 2 plus 4. We know that 2 plus 4 is 6. Okay. The next value that I'm going to add, this is where it's really important. I'm not just adding 5 plus 6. I'm adding 50 plus 60. Okay. So this partial sum, 50 plus 60. Okay. That is equal to 110. So because I have 110, I do have a digit that's already over in that hundreds place. Okay. And then finally, I need to add my hundreds. 200 plus 100, which is a total of 300. And then I'm going to add my ones, my tens, and my hundreds. And again, teachers, it's very important to use that correct vocabulary here. So students know that the 6 represents 6 ones. This one represents 110. However, this one represents 100. So I have 6 ones, 110, and 4 100s or 400s. So again, I get the same answer, 416. You'll see a very similar process as we use with expanded form. And this is called partial sums. It's another strategy that students can use to help them add 2 whole numbers. Remember, teachers, that it is not required that students master every strategy that you teach them for addition. However, it is important that we help our students to build fluency. So we need to help support them in developing effective strategies to add whole numbers within 1,000. Students will begin to add whole numbers within 10,000 for AKS2 later on in Unit 4. Take a look at this problem for AKS2, IOA 2A. This is a subtraction problem, and we are going to talk about some subtraction strategies you can use in your classroom. We want to make sure that we are modeling for students how to examine a situation or a problem that they've been given and analyze to see, what operation am I trying to solve? This modeling and this think aloud for students is so important because we don't always know which strategy we should be solving. So make sure we are modeling for our students to help them see how they can think through a problem to determine, do I add in this situation or does this situation ask me to subtract? So let's take a look. Mark is collecting cans for recycling. He collected 712 cans and 388 bottles. How many more cans than bottles did Mark collect? So let's think about, what do I know in this problem? I know that Mark is collecting items to recycle. We know that he collected 712 cans, and we know that he collected 388 bottles. So let's take a look at the question I'm being asked. How many more cans than bottles did Mark collect? How many more? I need to figure out how many more, because I know 712 is more than 388. It's greater than that number. So I need to figure out how many more cans. Let's draw a model to see what this looks like. I can use a bar diagram, and a bar diagram is going to help me to see the values of my numbers. I'm going to let this bar represent 712. Okay, that is representing the number of cans Mark collected. Now let's draw a bar model to represent the number of bottles that Mark collected. Now remember, I already know that 388 is less than 712. How do I know this? Well, I know that 300s is less than 700s. So that means his bar for the number of bottles is going to be shorter. So now I have a model to represent the total number of cans, the total number of bottles. I'm comparing these two values. This is a comparison problem. I'm trying to figure out how much more is 712 than 388. I need to know this difference. So guess what? I can find this using subtraction. Let's write a subtraction equation to help us solve this problem. 712 minus 388 equals how many more cans than bottles does Mark have? Okay, I've thought through my problem. I've done a think aloud, I've analyzed it, I've drawn a model to help me set up what equation I might use to solve. I have determined it's now subtraction. So now I can start working with strategies to help me solve this subtraction problem. Okay. One thing that you can always start with are base 10 blocks. That is very helpful to provide that concrete experience for students. If students are struggling with the more representational strategies, always bring back those concrete manipulatives in your small groups. So let's take a look at how I can represent and solve this subtraction problem using drawing of base 10 blocks paired with the expanded form equation. We like to do this because that expanded form equation tends to be a little bit more abstract for students. And when we pair the workings of the base 10 blocks with the expanded form, it really helps provide that visual representation for students. So to help me with this, let's start with the place value chart. I like to use a place value chart because that keeps all the pieces of my problem nice and organized. And mathematicians really need to keep their work organized to help others be able to understand the work that is happening. So I take a look at my problems here, and I notice I have two 3-digit numbers. So that's how I knew I only needed my 3 place values. And those place values are my hundreds, my tens, and ones. Now, remember in 2nd grade, they have already worked with the place value of 3-digit numbers. They have added with 2-digit numbers. So they are familiar with the tens and ones, and we're incorporating subtracting using also hundreds. So one common mistake that students tend to make is accidentally representing both numbers when they are subtracting. When I am subtracting using base 10 blocks, I only need to represent this first number, and this amount is the amount that I am subtracting from the value, okay? So I'm going to represent 712 using base 10 blocks. At the same time, I'm going to use those values to help me with that expanded form equation. So I know I have 700s, 1, 2, 3, 4, 5, 6, 7. So I'm going to go ahead and write 700 as part of my expanded form equation. I know I have 110. So my value is just 10. And finally, I have 2 ones. So I have represented 712, which represents the total number of cans, and I'm trying to figure out how many more bottles or how many more cans than bottles Mark has. So I'm subtracting to figure that out. So I'm going to subtract 388 from this amount. So because I'm going to subtract that amount, I'm going to write this 3-digit number in expanded form because I need to subtract each one of those pieces from this original number. So I am subtracting 388. I have 300s, 8 tens, and 8 ones. I always like to make sure I model that for students to make sure they are double checking that their digits match the digits in the problem, because oftentimes students have done all of the math correctly, but they used an incorrect digit. So let's make sure that we're helping students to really attend to that precision and to go back and check that work, okay? So as I subtract, okay, I am going to be subtracting 8 ones, 8 tens, or 80, and then 300s from this value. Okay, so this is where these two pieces are going to start working together. All right, so I'm gonna push this up a little bit so we have a little bit more room for you to see. So I'm gonna start in the ones place here. I have 2 ones, I see that, and I'm having to subtract 8. Now remember, students are going to see this addition sign there, and some might accidentally add 2 and 8. So we need to make sure that students remember what operation they are using to solve. 2 ones minus 8 ones. As my model shows, I only have 2 ones in my ones place. However, I can represent this number differently in order to take 8 ones away. So how can I do that? I can use this 110. And I can take this 110, and I'm just going to mark it off because I want to show that it's being used. And I'm going to rewrite it as 10 ones because I know that 110 has the same value as 10 ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I just regrouped what I already had. Okay, I like to write it as 2 groups of 5 just to show that group of 10 to relate back to this 110. So now let's what we just did with our base 10 blocks, let's show that on this expanded form equation. I no longer have 110, I have 0 tens, okay? I no longer have a value of 10 in this column because that no longer is there, and my ones place has increased. I don't have just 2 ones now, I have 12 ones, okay? So now, when I look back at my model, 12 minus 8, I can subtract 8, 1, 2, 3, 4, 5, 6, 7, 8. And I see that I have 4 ones remaining. So there is 4 in my ones place. I go ahead and I like to go ahead, write the addition sign because I know my answer here is going to be written in expanded form. And when I'm finished with my subtracting, I can add those pieces back together to get my final answer in standard form or written as base 10 numerals. Okay, let's move our way to the tens place. I don't have any tens anymore, okay? The way I was working, I had 110, I regrouped it, so now I'm left with nothing. However, there is another way that I can represent the same value by exchanging one of my hundreds. So this is where that flexibility with representing numbers is so important. So remember, this 100 has the same value as 10 tens, okay? That is the value of 100, is 10 tens. So I'm going to take that 100 and I'm going to rewrite that as 10 tens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 tens. Or I can count by tens, and I realize that now my tens place has a value of 100. But my hundreds place, instead of having a value of 700, now has a value of 600. So let's show that over here. So my hundreds place, I can quickly see it has a value of 600. And my tens place now has a value of 100, okay? Because I now have 10 tens. Notice how I did go ahead and cross off that 0. I didn't add digits around that because I wanted to show that process of what is happening. And so this is where being very organized is very helpful. So now I can subtract in my tens place. 100 minus 80, or 10 tens minus 8 tens. I'm going to be left with how many tens? 5, 6, 7, 8. I'm going to be left with 20 tens. Okay, and that makes sense. 100 minus 80 is 20. All right, I'm down to my last place value, 600 minus 300. I'm going to cross off 1, 2, 300s, and I'm left with 300. So after I've subtracted and I take my expanded form, 300, 20, 300 plus 20 plus 4, written in base 10 numerals, I have 324. There are 324 more cans than bottles that Mark collected. Now remember, teachers, this is one strategy that you can use if students are struggling to see this regrouping within the expanded form. Definitely pair that with your base 10 representation, okay? Also want to note that as you start regrouping, you might not want to regroup in 2 place values at the same time. Maybe only regroup your tens and ones in a problem, and then maybe have some problems where you only regroup your hundreds and your tens. That'll help scaffold that work for students. Now, this isn't the only strategy that students could use. Students could also use what is called partial differences. And this is definitely more abstract, but it definitely also relates back to the work we've done here with expanded form. So let's take a look at that. I'm going to rewrite my problem again, just so we can see. what is happening. Okay. Now, when I work with partial sums, one thing I need to remember here is that I'm going to subtract these pieces, just like we did over here, a little bit at a time. I don't have to do it just in the one chunk, though. I'm going to show you what that means here. So I need to I'm going to take away parts of this number. So I know that 388 is the same as 300 plus 80 plus 8. Okay. Also, remember, teachers, I don't need to do both of these strategies on the same day. Okay, so this strategy could be a different day. So I know 388 is the same as 300 plus 80 plus 8. So I am going to subtract these pieces a little at a time. So I have 712. And I'm going to start out by subtracting 300. I'm actually going to go to this color. So you can see. I'm going to go ahead and subtract 300 here. So 712 minus 300, I'm going to be left with 412, right? Because I had 700s, and I'm going to take away those 300s, and I'm left with 412. Now remember, partial differences. I'm subtracting in parts. So now what do I have left of that total number? And in this case, that 712 was the number of cans. I now have 412, right? And now I need to subtract 80. Well, when I'm looking at this number is very close to 400, right? So I can't subtract 80 as easily as I could maybe if this number was 492. So I'm going to subtract this in parts, okay? I'm going to go ahead and subtract 10. Why did I subtract 10? Well, I know 412 minus 10 would be 402. Okay, so I took this 80 and I decomposed it into two parts, 70 and 10. Okay, so I'm just going to keep track here. I have 70 left to subtract. Okay, just to help me as I do these pieces. Well, now I'm at 402. And before I subtract any farther, let's maybe go ahead and take away another 10, because I want to take this nice and steady. And if I go back, and I'm thinking of a number line here to help me with this piece, if I go back 10 on a number line, 402 minus 10, I'm going to be left at 392. Okay, so notice here I've taken away two 10s, so I'm now left with 60. Okay, I had 80, but I took away 10, and then I took away another 10. And now I have 392. Well, if I go ahead and subtract 60 from 392, I'm left with 332. So I subtracted those in parts because that's what made most sense to me. I could have just subtracted 80 and got down to 332, but students will have to have a really strong understanding of where that's happening on that number line. All right, I'm not done yet. I've subtracted my hundreds. I've subtracted all my 10s. Now I need to go back and subtract my ones. So 332 minus those 8 ones. I'm going to be left with 324. And notice my answer is the exact same as when I solved using the expanded form. Multiple strategies that you can use for subtraction. It's important that students select the one that makes the most sense to them, with the partial differences definitely being that more abstract. Remember, teachers, in quarter 1, unit 1, we're only working with numbers within 1,000. In unit 4, students will begin to work with numbers up to 10,000. So, which strategy? In mathematics, the emphasis is on the reasoning and thinking about the quantities within mathematical contexts. Specific mathematics strategies for teaching and learning are not mandated by the Georgia Department of Education or assessed on state or federally mandated tests. Students may solve problems in different ways and have the flexibility to choose a mathematical strategy that allows them to make sense of and strategically solve problems using efficient methods that are most comfortable for and make sense to them. It is critical that teachers and parents remain partners to help each child grow to become a mathematically literate citizen. These standards preserve and affirm local control and flexibility. This is from the Georgia DOE's Comprehensive Grade Level Overview. Thanks again. We appreciate you watching.